Fundamental of Physics 10th edition. Today I am going to solve some selected problems from chapter number 16 and chapter number 17, Waves part 1 and Waves part 2. Let us start from chapter number 16, problem number 28, wave equations. So in this problem we will use the wave equation in order to find the speed of wave. So here is a problem number 28. Use the wave equation to find the speed of wave given by this wave equation. Y is a function of t, which is equal to 3 mm sine 4 per meter x minus 7 per second t. So first of all, let us write the general wave equation which is given by y, which is function of x and t, equal to ym, where ym is the amplitude, maximum amplitude, sine of ax minus omega t. So this is a wave equation, traveling wave. Here ym is the maximum amplitude and this term is known as phase of the wave. So we will compare this wave equation with general wave equation. So you see that 4 which is multiplied by x is actually k, and 7 multiplied by t is actually omega. And speed of wave is given by omega divided by k. If you divide omega by k, you will get the speed of wave. So this is the omega, which is 7, and k is equal to 4. If you divide 7 by 4, you will get 1.75 meter per second. Unit of wave is meter per second. So this is the answer. Velocity, speed of wave is 1.75 meter per second. So this is the answer. So here is another selected problem from the same chapter 44. A 25 centimeter length of string has mass 2 kg and tension 7 Newton. What is the wave speed of this string? What is the lowest resonance frequency of this string? So let us draw a string whose one end is attached with a wall, and the second end is hanged by a mass which will produce tension. And the string, this is the length of string, which is 125 centimeter, and the mass of this string is 2 gram, and tension is 7 Newton. So let us find the A. What is the wave speed of this string? So speed of string is given by this equation, under root of tau mu. So tau is actually tension, but we have to find the mu, which is the linear mass density of string, which is given by m upon L. M is the mass, which is 2 times 10 to the power minus 3, and L is the length. So we will convert this length into meter, 1.27, and mass into kilogram, which is 2 times 10 to the power minus 3. So if you divide this by this, you will get 1.6 times 10 to the power minus 3 kilogram per meter. Now we will use these values into this equation. V equal to under root 7 divided by 1.6 times 10 to power minus 3, and if you calculate this you will get 66.1 meter per second. So this is the speed of wave for this string. Part B, what is the lowest resonance frequency of this string? So frequency is given by V upon lambda. V multiplied by N upon 2L, because lambda is equal to 2L upon N, where N is 1, 2, 3, and these are the resonance frequencies. So for lowest, N is equal to 1. So for N equal to 1, frequency will become V, N is 1 divided by 2, and length (66.1), 1 divided by 1.25 meter. If you calculate, you will get 26.4 hertz. So this is the answer. So now we will solve another selected problem from this chapter, problem number 53. A string oscillates according to the equation y prime equal to 0.5 centimeter, sine of pi by 3 per centimeter into x, cos of 40 pi per centimeter per second into t. What are the A, amplitude, and B, the speed of two waves identical except for direction of travel, whose superposition gives this oscillation? C, what is the distance between the nodes? D, what is the transfer speed of a particle of the string at a position x equal to 1.5 centimeter when t is equal to 9 by 8 second? So let us solve the problem. Let us write a wave equation. So wave equation is given by this equation, Jearl equation for wave, y equal to y naught sine of kx cos omega t. So this is the wave equation for standing waves. So where this y naught is related to ym according to this equation, half m y naught. Here again you see that this is omega and this is the k. So let us solve part A. Ym is equal to half of y naught. So half multiplied by y naught is 0.5 centimeter. So this will be equal to 0.25 centimeter. So this is the amplitude of wave. B, the speed of two waves. So we have to find the speed. Speed is given by v, which is equal to omega divided by k. So here omega is this term is omega and this term is cos. So omega is 40 pi and k is 4 by 3 pi, and k is pi by 3. So this will equal to pi cancel out, and this 3 will multiply by 40. So we will get 120 centimeter per second. If you convert into SI, then it will be equal to 1.2 meter per second. So this is the answer. Part C. What is the distance between nodes? So first of all, we will calculate the wavelength of this wave. So wavelength is given by 2 pi upon k, and k is pi by 3 because this is the k, pi by 3. So again pi cancel out, and this 3 will multiply by 2, so we will get 6 centimeters. So this is the wavelength of this wave, and the distance between node and antinode is half of this wavelength. So we will divide this 6 centimeter by 2. So we will get 3 centimeter. So this is the distance between nodes. And now we have to find the transferred speed of the particle, which is given by u, which is function of x and t. And if we differentiate this term, then we will get u. So this is the part D. So u is equal to dava y prime divided by dava t. So dava divided by dava t. So y is the this equation, 0.5 centimeter sine of pi by 3 per centimeter into x multiplied by cos of 40 pi per second into t. So now we will differentiate this with respect to time. So this time is only in this function, cos function. So we will differentiate this cos from only because it includes time, and the derivation of cos is minus sign. So we will put here minus. Then this whole term 0.5 centimeter sine of pi by 3 per centimeter into x, and here we will write the sign because derivation of cos is sine. Sine same term 40 pi s minus 1 into t. So now we have to find when x is equal to 1.5 centimeter and time is equal to 9 by 8 second. So we will put this value into this equation, then u will be equal to minus 20 pi centimeter per second because 40 into minus 5 will become 20 pi sine pi by 3 into x. So x is 1.5. So multiply by 1.5 sine 40 pi t. So t is 9 by 8. Eight multiply 8 divided by 40, we will get 5, and this 30 with 1.5, so this will become 20. So u will equal to minus 20 pi, and pi by 20 sine 44 pi, and we know that sine pi by n is equal to 1, but sine n pi is equal to 0. So this is the n is the any number, 1, 2, 3, 4, 5. So this term will be equal to 1 and this term will be equal to 0. So 0 multiplied by anything is equal to 0. So we will get 0. So velocity will be equal to 0 meter per second. So this is the answer.